First of all, what the heck is nuclear energy? Well, energy production through atomic handling comes from nuclear fusion and fission processes, as well as radioactive decay. Nuclear fusion consists on atoms' union to create heavy atoms, while fission processes means an atomic nuclei division. Both techniques set huge amounts of energy free in the form of heat. The discovery of the amount of energy that can be produced from such a tiny source like an atom made scientists and researchers study the ways humanity could take advantage of it. Historically, the first approach to realize about the existence of this kind of energy was made by Democritus, a Greek philosopher from centuries 5th and 4th before Christ, who proposed that any material, even if it was split, preserved all of its original properties, but after a certain number of divisions, the resultant pieces would be so little that they would be indivisible. More than 2,000 years after, in 1911, Ernest Rutherford discovered the atom nucleus, starting a series of studies and experiments that allowed the German scientists Otto Hahn and Fritz Strassmann to discover and understand the nuclear fission reactions. Soon, the Italian scientist Enrico Fermi contributed to this work by developing the first self-sustained nuclear fission reactions chain, which meant the beginning of nuclear age in the world. It must be noted that the whole planet met nuclear power with the atomic bombs that targeted Hiroshima and Nagasaki in Japan that ended World War II in August of 1945. To produce nuclear energy in a controlled environment from nuclear fission chain reactions, it is necessary to build a nuclear power plant, whose central component is a reactor, the one where the uranium used as fuel is deposited in the form of logs. After the reactor burns the uranium, the nuclear fission starts, so the atoms liberate an enormous quantity of heat. This heat travels through big water deposits to create steam, which is conducted at a high pressure through pipes to a set of turbines. Using the steam as a propeller, the turbines start to rotate at high speeds. This movement produces mechanical energy that is turned into electrical energy using a generator. Uranium plays a key role for nuclear energy because it has the only universal isotope among known elements that can produce a fission chain. To do this, uranium must be chemically enriched to maximize its properties. This type of uranium is called uranium-235 and is the most commonly used at nuclear power plants. Nuclear power plants have been historically satanized all over the world because even when the number of accidents is very little to compared to the ones occurred in other industries, damage caused by them are much bigger and catastrophic, and their impacts have even crossed borders. The incidents in Chernobyl, Ukraine, and Fukushima, Japan, are the most infamous tragedies about nuclear energy. Jointly counted, both events forced the evacuation of nearly 500,000 people and allowed the spreading of radioactive material out to the atmosphere. Also, the epicenters were declared exclusion zones due to the radioactive pollution. Since then, a negative opinion has generalized in the public audiences, ignoring the advantages that nuclear energy offers. It is important to remark that while the Chernobyl accident was caused for security protocol violations made by the plant workers, the one at Fukushima was a result of a natural disaster, specifically a 9 Richter grade earthquake and a successive tsunami, what exposed the vulnerability of nuclear facilities to nature forces. Right now, there are around 450 nuclear reactors working, distributed among 33 countries in the world. The nuclear energy share of the total produced globally is about 10%, with USA producing more than 30% of it. Other important nuclear producers are France, Russia, and Canada, with China increasing its capacity notably. In this moment, about 52 power reactors are currently being constructed in 16 countries, including China, India, Russia, South Korea, and the United Arab Emirates. In contrast, some countries have decided to phase out nuclear energy, like Germany, Italy, Switzerland, or Belgium, or remain nuclear-free, like Denmark, Portugal, Austria, and Ireland. The current price of uranium is around $60 a kilo, so this is a big concern for this industry due to its highly volatile status.
Now we will look at the two sides of the coin, the pros and the cons of nuclear energy. Starting with the pros, one of the most outstanding advantages of nuclear energy production is that its carbon dioxide and greenhouse gases emissions are practically zero versus the emissions that traditional energy sources suppose. This contributes in the battle against climate change and global warming. Among its main advantages over fossil fuels, nuclear energy needs just small amounts of mineral to generate a huge quantity of electricity. For perspective purposes, a single pound of uranium is capable of producing the same energy than 50 tons of coal. Also, the relative use of land is on nuclear energy's side because, ironically, renewable energies require a lot more space and land, damaging the ecosystems where they are installed. In contrast, nuclear energy is lowly intrusive. On the social and economic welfare approach, nuclear energy projects are job-intensive and create a considerable number of new direct long-term jobs. And the inherent supply chain that the nuclear complex needs to work generates an even bigger number of indirect jobs. Thus, productive and economic chains around the power plant bolsters the economic growth and provides employment stability to the region. Besides, as the number of resources extracted is minimal compared to other mineral sources, it has a low cost provisioning. And even when the construction of nuclear power plants may be costly, the long-run economical savings and benefits amortize and outnumber the financial and supplies costs, while reducing environmental costs at the same time. Time efficiency aspect must be added because nuclear power is capable of maintaining a constant supply 24/7 of energy and that can easily adapt to the changing demand of cities, while renewable energy systems operation depends on the environmental conditions and times of the day. And in the other hand, we have the cons. The main worry about nuclear energy production is the latent risk of an accident. Even when the probability of a severe incident in a nuclear power plant is very low, if this happens, the effects used to be devastating for a large number of people due to radioactive leaks, which causes several diseases and public health issues. Radioactive waste management is also a big issue because there is not a single technique or technology that guarantees a riskless, environmental friendly, and completely safe management of these wastes yet. Right now, the best way that the nuclear community has found to deal with the radioactive wastes is creating natural repositories and modify them to contain radiation. This, of course, is not a sustainable approach. Another general disadvantage for nuclear energy is that although it requires small quantities of uranium to work, these elements remains being exhaustible, pushing the industry to look for a viable substitute with the same degree of efficiency. In order to evaluate the degree of sustainability that nuclear energy can reach, aspects such as safety, environmental benevolence, natural resources durability, social welfare, and technology's economic viability must be taken into consideration. Several questions about this topic emerge, and it is inevitable to discuss them. First of all, radioactive wastes management highlights the concerns about nuclear activities. Therefore, to be considered as a sustainable source of energy, the nuclear waste management technology must improve significantly a long time. Another condition is the availability of raw materials for its performance at all times, bearing in mind that the necessary resources comprise not only the physical portion of the same, but also their location and availability of suitable technology to exploit them, including the calculation of the prices associated with its transformation and taking into account changes of costs in uranium and future patterns of energy consumption. A third heading is its infrastructure durability, because the average useful time of nuclear reactors may enable near future generations to benefit in the same or higher level than us in the present. But certainly uranium reserves won't last forever, making far future people unable to enjoy from this resource. But given the long duration of radioactive waste effects, they certainly will have to deal with the remnants of present nuclear activities. The final big concern identified is the armament and warlike use that has been historically given to nuclear applications development. If humanity can come up with a flawless strategy to avoid nuclear bombs launching, sustainability will be out of the discussion. Destruction is incompatible with sustainability or development. Bibliographic references. Thank you for your attention.